Good afternoon, everyone. Good afternoon, sir. I am Jeanette Escala, and for today's discussion, I will be discussing about electrochemical methods. We have here first the objectives. At the end of the lesson, you are expected to define electrochemistry, define electrochemical methods, and learn about potentiometric method, its instrumentation and equipments, and its applications in various fields. Now, let's define electrochemistry. It is a branch of chemistry concerned with the interaction of electrical and chemical effects. It is named electrochemistry because it originated from the study of the movement of electrons in an oxidation-reduction reaction. So, ang electrochemistry daw ay isang branch ng chemistry na concern sa interaction ng iba't ibang electrical and chemical effects. Pinangalanan itong electrochemistry dahil nagmula ito sa study sa pag-aaral ng mga movement or ng mga paggalaw ng electrons sa isang oxidation-reduction reaction. Moving forward, we have here the electrochemical methods. It refers to the process of oxidation-reduction reaction in a circuit composed of electrolyte, cathode, and anode under an external voltage to precipitate the required elements on the cathode or etch the anode. Kapag sinabi po nating cathode, it is the electrode where reduction occurs or when the electrode gains electrons. Kapag sinabi naman pong anode, it is the electrode where oxidation occurs or when the electrode loses electrons. Electrochemical methods are analytical techniques that utilize measurements of potential, current, or charge to determine an analyte's concentration or characterize its chemical reactivity. So, ang mga electrochemical methods po ay mga analytical techniques siya na ginagamit para ma-measure ang mga potential, current, or charge ng iba't ibang concentration ng mga analyte. Let's discuss now the potentiometric method. So, potentiometric method is based upon the principle of measuring the voltage difference between two electrodes immersed in a solution. So, kapag gumagamit po tayo ng potentiometric method, ang ating minimeasure po dyan ay ang voltage, ang magkaibang voltage ng dalawang electrodes na nakalagay sa isang solution. So, one of the electrode is the reference electrode, and then the other one is the indicator or the measuring electrode. Potentiometry is based upon the general principle that the relationship between the potential of a measuring electrode and that of a reference electrode is a function of the log of the activity of an ion. This relationship is given by the Nernst equation. Now we have here the Nernst equation, wherein E stands for the measured potential. The following one is the standard electrode potential. And then the R stands for the gas constant, the T is the absolute temperature, the N is the sign charge, positive for cations and then negative for anions. The F here stands for the Faraday constant, and then lastly, the Q stands for the activity of the ion being measured. Moving forward, this is how a pH meter diagram look like.
pH is a measure of the concentration of hydrogen ions in a fluid. The most common method for online pH measurement is potentiometric glass pH sensors. These sensors work by producing an electrical voltage that is proportional to the hydrogen ion concentration in the fluid. pH sensors have two primary components, a pH-sensitive electrode and a reference electrode. Both electrodes consist of a metal wire suspended in a stable neutral electrolyte solution. The reference electrode maintains a steady reference voltage and completes the electrical circuit with the pH-sensitive electrode by allowing a small amount of ions to flow from the reference electrolyte solution into the process fluid through a small porous opening called a reference junction. The pH-sensitive electrode has a small bulb at its tip that is made of pH-sensitive glass. The electrical voltage across this bulb changes in response to the hydrogen ion concentration of the process fluid around it. If the hydrogen ion concentration is higher on the outside of the glass bulb than on the inside, a positive voltage occurs, indicating the process is acidic. If the hydrogen ion concentration is lower on the outside of the glass than on the inside, a negative voltage occurs, indicating the process is basic. If the hydrogen ion concentration is the same on each side of the glass electrode, the voltage is 0, indicating the process is at a neutral pH of 7. The pH of the process fluid is calculated from the voltage difference between the pH-sensitive electrode and the reference electrode.
We also have here the equipments in potentiometric method. The first one po is the indicator electrode. This electrode is designed to respond to changes in activity of the analyte in a solution. So kapag sinabi po nating indicator electrode, yung potential niya po ay nagbabago-bago as a respond doon sa ginagawang concentration or activity ng specific ion or ng analyte. Some common examples of indicator electrodes are some metal electrodes like silver, copper, and then platinum. The second one is the reference electrode. It has a stable and well-known electrode potential, which serves as a reference point for measuring the potential of other electrodes. So, ang reference electrode po ay hindi siya nagbabago-bago, even with the concentration or the different activities of an specific ion or an analyte in a solution. Ginagamit po ang reference electrode sa pag-measure ng ibang electrode katulad na lamang ng mga indicator electrodes. And then the third one is the potential measuring device, the instrument used to measure the difference in electrical voltage or electrical potential between 2 points in a circuit. We have here the two types of potential measuring device. The first one is the potentiometer and then the voltmeter. So in potentiometer we have two devices. The first one is the rotary potentiometer. This one acts like as a variable resistor. Rotating the shaft changes the resistance value. And then it is commonly used for volume control, brightness adjustment, or tuning in circuits. The second image is called the signal conditioning module with BNC connector. Signal conditioning or amplifier module often used for analog signals like from sensors or oscilloscopes. And its primary function is that it amplifies or processes analog signals, usually from sensors or measurement devices. Now we have here the applications of potentiometric method. The first one is clinical chemistry. Ion selectively electrodes are present sensors for clinical samples because of their selectivity for analyte in complex matrices. Then the second one is the environmental chemistry for analysis in water and wastewater. So ginagamit din po ang potentiometric method sa pag-a-analyze ng mga water and then ng mga wastewater, yung mga gamit ng tubig. The third one is the potentiometric titrations for determining the equivalence point of an acid-base titration. Possible for redox, precipitation, acid-base, completion, as well as for all titrations in aqueous and non-aqueous solvents. Then we have also here the agriculture for analysis in soils, plant materials, feedstuffs, and fertilizer. So ginagamit din po pala ang potentiometric method sa agriculture in terms of analyzing the soil, the plants, materials, and then the feedstuffs and fertilizer, yung mga pampataba. And then we have here also the detergent manufacturing for studying its effects in water quality. Yung mga ginagawang detergent, kung ano ba yung mga epekto nila sa tubig. And then lastly, we have the food processing for analysis of the contents of food and beverages. So, yung food processing naman, ginagamit yung potentiometric dito para i-analyze yung mga laman, yung mga contents ng mga binibentang pagkain. Katulad na lamang ng mga chichirya, yung mga soft drinks. Yan. So that's all po for my presentation. I hope you learned something, and then thank you for paying attention.